us look at this by this small activity. I have a number line here. A vehicle is parked in front of 0 and another one is placed here. x0, as we recall, meant the position at time 0. This would mean at instant 1. This would mean position at instant 8 and so forth. So, the change in position would be reference to the time as well. So, let us start our time here and move this vehicle. Notice it is moving in the negative direction, but the distance that it is travelling is positive. If it goes from 0 to the other direction like this, so there is positive position and the distance that it has covered is starting from here, going this side, going to that point and coming back again to 0 position, which means the displacement in all this time interval is 0, but the distance it has travelled is a lot more. So, distance is always going to be positive, while displacement can be 0 as we have seen just now, could be negative if it is belonging to this side of the number line, or it could be positive if our vehicle was somewhere here at the end of certain time. In order to understand different words and different ways in which we look at motion, our focus now would be to consider motion as change of position with time. We explain this by two terms, distance travelled and displacement. Displacement can be negative, 0, positive, but the distance travelled is always positive. There is a difference between distance travelled and displacement. We can describe motion by position time and displacement time graphs. We are going to take an example using a number line. When an object moves, its position coordinates change. In one-dimensional motion, only one position coordinate changes along any of the x, y or z axis. The position may be described in many ways. If x1 is the initial position of an object at time t1 and x2 is the final position at time t2, or we can say x0 is the position at instant 0, which is when we start considering the motion, and xt the position at instant t. X minus t would be a position before we start considering the motion. We can say the distance travelled is xt2 minus xt1 in time interval t2 minus t1, or xt minus x0 in time interval t minus 0. So, let us look at this by this small activity. I have a number line here. A vehicle is parked in front of 0 and another one is placed here. x0, as we recall, meant the position at time 0. This would mean at instant 1. This would mean position at instant 8 and so forth. So, the change in position would be reference to the time as well. So, let us start our time here and move this vehicle. Notice it is moving in the negative direction, but the distance that it is travelling is positive. If it goes from 0 to the other direction like this, so there is positive position and the distance that it has covered is starting from here, going this side, going to that point and coming back again to 0 position, which means the displacement in all this time interval is 0, but the distance it has travelled is a lot more. So, distance is always going to be positive, while displacement can be 0 as we have seen just now, could be negative if it is belonging to this side of the number line, or it could be positive if our vehicle was somewhere here at the end of certain time. So, the negative sign in our reference only refers to direction. We are going to describe motion by using graph. What kind of graphs can we draw? Since we are dealing with two quantities, one the distance and the other displacement, we can have a choice of two types of graphs. One is a distance time graph and the other would be displacement or position time graph. Both these graphs are capable of telling us how a particular object is moving. We will take up an example to make this clearer. Savita lives on the same road as her school. She cycles 2 kilometers in 10 minutes to reach the school. She spends 5 minutes in the school and realizes that she has forgotten her physics copy at home. She returns home again, covering 2 kilometers in 10 minutes. Now let us use a graph to show her motion. When we graph distance time or position time, on the x-axis we keep time, because time is not dependent upon the distance. Therefore, we keep the quantity which is independent on the x-axis. So, our xt graph means position time or distance time graph. So, x or position would be on the y-axis. Let us consider our problem again. Savita lives on the same road as her school. She cycles 2 kilometers in 10 minutes to reach the school. She spends 5 minutes in school. We will assume that she is in school, within school, so she is not moving or having a displacement per se, and realizes that she has forgotten her physics copy at home. So, she returns home again, covering 2 kilometers in 10 minutes. In order to graph this data, let us plot. As we've just said, that on the x-axis we have time, and because it's all in minutes, what we have done is that time in minutes we take 1 unit to be representing 5 minutes, and on the y-axis we have distance in kilometer. So, we choose a unit of 2 unit to be equivalent to 1 kilometer. So, this graph, notice, starts from 0. So, 0 time means when you started talking about the motion. So, when she left the house. So, 0, and she covers this entire journey in 25 minutes and reaches 2 kilometers for the school. Then she stays there for 5 minutes. That means there is no motion at all. So, we have a flat line, flat meaning parallel to the x-axis, and this line is showing the position to be at distance at 2. So, position is not changing. So, the person is stationary. For the next part of the journey, again for the next 10 minutes, she has travelled a distance of 2 kilometers. So, the total journey is shown, and you can see that the total distance of travel is 4 kilometers, 2 to go and 2 to go back to her house. So, from school to house again 2 kilometers. So, the total length of journey is 4 kilometers, which she has done in 25 minutes. So, 10 minutes for going, 10 minutes for coming back, and 5 minutes for staying in school. Now, let us look at the second graph. The second graph is a position time graph. Notice in this one again, the x and the y axis seem to be the same. Starting from 0, 0, she moves along and reaches a position of 2 kilometers in 10 minutes time duration. 5 minutes she spent in school, and then she goes back home to pick up her physics copy. So, that journey is shown by another line, the slope of which is exactly negative of the first one. Notice the end of that line is also on the x-axis. The suggestion over here is that the displacement, net displacement is 0 for the girl. So, Savita went to school, came back home, 0 displacement is indicated by the position time graph. Now, both these graphs are correct, the distance time as well as the position time graphs. And if you carefully understand it here, they are showing you something different. In the distance time graph, you have no notion as to where this person is at the end of 25 minutes, while the position time graph is able to tell you that this person is back home. That means at the starting point. From our example here, it would mean that this person has travelled a certain distance this way and has come back. The distance time graph is showing that you went to this distance and travelled another distance. So, the distance time graph is only going to have a positive increase on the y-axis, whilst the position time graph is capable of telling you that you moved in one direction and then in the other, and therefore, it is showing you where exactly is Savita at the end of a certain time interval. Now, it is not necessary that the person goes right back home. The displacement could be anything. For example, this particular car starting from 0 would have moved in the positive direction and would have gone back like this and in some negative value. Notice the distance would have been from starting from this point like this and back to this and again continuing. So, the distance time graph in this case also would have remained straight line, and you would have no point or no chance of saying that okay, it turned back. But a position time graph would be able to tell you that okay, it went in this direction and then it returned and then it went further ahead in the same negative direction. So, both the graphs have different capabilities. However, they are both correct and both are used for different purposes in talking about kinematics and motion in a straight line. We will take up another problem. This problem is about a drunkard. You know that drinking is very bad and it is injurious to health and should not be done. However, we are taking up the problem because it suggests some things or is able to tell us about our two terms that we are talking about, the distance and the displacement. It is for that reason that we are taking up the drunkard problem now in this lesson. Let's see what the problem is. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed by 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and requires 1 second. Plot xt graph of his motion, determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meters away from start. So, now to imagine our question, we have a strip here with these white markings. The distance between each of these is 1 meter, and say this toy represents the drunkard and this is the 0 point. So, 13 meters away is the pit. So, counting from here, this is 13. So, he will fall into the pit at this point. Starting from 0, he goes in a narrow lane. So, it becomes a question of motion in one dimension. So, only along this line are we considering the motion. So, starting from here, he goes 5 steps forward, 1, 2, 3, 4, 5, and the time he takes is 5 seconds as mentioned in the question. Then he goes back 3 and comes to this position. So, if you consider the time that has elapsed, 5 to go forward and 3 to get back, so total of 8 seconds, and the displacement from the 0 point to this one is only 2 meters. I will repeat this for you. This is his starting point, 1, 2, 3, 4, 5 meters forward, 1, 2, 3 meters backwards. So, the total distance travelled is 8 meters, time elapsed is 8 seconds, the displacement from the starting point is only 2 meters and in 8 seconds. So, we have to see in the next 8 seconds what happens to him. He goes 1, 2, 3, 4, 5 forward and 1, 2, 3 backwards. So, net displacement from the 0 position is 4 as you can see, but he has travelled in the next 8 seconds from the beginning, 8 seconds he had done earlier, another 8 seconds, so 16 seconds have elapsed and he has travelled a distance of 16 meters. However, his displacement from initial position is only 4 meters. So, we have to find out when will this person have a displacement of 13 meters and fall in the pit. So, therefore, let us look at it again, 1, 2, 3, 4, 5 and 1, 2, 3. So, he has reached here in 24 seconds. So, you can do this problem mathematically as we are proceeding right now, or you can use a graph. Mathematically, one point to remember is that when he is at a distance of 5 from this place, then in the last 5 seconds he is going to fall into the pit, and therefore, you in the total time or the total displacement or the distance travelled, you must remember that the last 5 seconds is to be taken into account. Such type of calculations can be cumbersome, but we can do this easily using a graph. I am going to refer to making a graph by using a GeoGebra app. GeoGebra is free, you can download it, and when you download that and open the page, you will see this. Under view, you click on it and then option is spreadsheet. Choose the option spreadsheet. On the right hand side, a spreadsheet arrangement will be there, which has got A, B, C columns. In A column you put time, and in the B column you put distance, and in the C column you can put displacement. Care has to be taken that you fill this carefully. So you fill the data keeping in mind the position of the man at the end of time interval. Example, at the end of 5 seconds plus 3 seconds, the man is at a displacement of 5 meters minus 3 meters equal to 2 meters from start. So our spreadsheet will look like this. In the first column, the time will go 0, 5, 8, 13. Why like this? Why not continuous time? Because at the end of 5 seconds, he is changing his position for 3 seconds going backwards. So it is easier then to find out how much distance is travelled at that time or how much of displacement has occurred in that time interval. And therefore, we have got for time 0, 5, 8, 13, 16, 21, 24, 29, 32, 37. And in the x one you have 0, 5, 8, 13, 16, 21, 24, same as what the time is. Because for every meter, the time taken is 1 second, and you see at the end 37 there again. In the last column, which is the most important one, it says 0, 5, 2. The displacement at the end of 8 seconds is 2 meters. The next one is 13 seconds time and 7 is the displacement. 16 seconds time, 4 is the displacement. 21, and likewise when you go to 37, you find 13 meters. That 13 meters is important because he would have fallen into the pit. And so, we have seen from here that the total distance travelled by this drunkard is 37 meters, and the time he takes is 37 seconds, and the displacement is only 13 meters. So, this is a very good example of calculating distance and displacement. Now, when you have finished putting these in the column, select data that you have just filled, right click and choose from the options create polyline. And you will see a wonderful spectrum in front of you. You will see a distance time graph and a position time graph all at the same time. It's indeed a very interesting way of looking at it because both graphs appear simultaneously. You can plot it on a graph sheet, but this gives you another option. Let us consider the distance travelled by Usain Bolt. Usain Bolt, born 21st August 1986, is a Jamaican athlete, regarded as the fastest person ever timed. He is the first man to hold both 100 meters and 200 meters world records as of today. Since fully automatic time measurements have become mandatory since 1977, we have timing for him. You can see him in the race. Usain Bolt's timings are given as an XT arrangement in this table. You can see for his 100 meters, when this particular timing was taken, he took 9.69 seconds. Now, you have a fairly good idea about a second. So, 9.69 seconds is indeed an awesome value for 100 meters of run. If we plot this again using our GeoGebra, you are going to see an incredible position time graph. You do the same thing. Take it on your spreadsheet, right click after selecting the spreadsheet, click on create polyline, and you get this steep curve showing you how Usain Bolt runs. So, we have learned motion is change of position with time. Motion is change of position and it can be talked of in terms of distance travelled and displacement, and time is important. You can describe motion by using graphs. You can quickly plot a graph using GeoGebra. You can plot both distance and displacement time graphs at the same time using GeoGebra, as we did in the case of the drunkard. And we get a sense of position of the body as it changes with time. So, to completely talk about motion of an object, we have to talk about the position at different times, and therefore, we can use graphs, we can use symbols to represent the change in position and the time interval involved in it.